Alright, so you should have finished your quizzes from yesterday, and now we are moving on to something that we call special right triangles. Alright, so special right triangles are special. There's some special rules for them that we're going to learn today so we can solve for missing side lengths. Okay, so follow along on the notes and you'll be able to do the assignment. It's usually how it works, right? So I'm going to be over here for this because the board's acting weird and I got to write on this. So here we go. By the way, go Commanders. Woo. All right. Here we go. 45, 45, 90 triangle. Okay. This is a special right triangle. Okay. Guess what the three angles of a 45, 45, 90 are? There's one right angle. So it's called a 45, 45, 90. Guess what the three angles are? What? If the name of the triangle is 45, 45, 90, what do you think the three angles are? "45, 45, 90. That was good. That was a good 2 minutes of thinking. That was good. All right. So, everybody, the name of the triangle is the three angles of the triangle, okay? So, let's do this. A 45, 45, 90 triangle can be formed from a square, okay? So I want you to think about a square that has four equal sides, right? If you took that square and you cut it diagonally in half, you would end up with a 45, 45, 90, okay? It's also called, now, by the way, 45 and 45, that's two equal angles. What do you call a triangle with two equal angles? Isosceles. So it's an isosceles triangle. And one of the angles is 90. What do you call that? Oh my gosh. Hold on. Yeah, that would be a isosceles right triangle because one of the angles is 90. Okay? Cool. So, with that information, we're going to be able to learn some rules. Okay? So, in a 45, 45, 90 triangle, the hypotenuse is blank times as long as each leg. It is square root of 2 times as long as each leg. Okay? Red hoodie guy, wake up. All right. Let's do this. Every time you do one of these problems, you're going to make this little chart right here. Okay? So you're going to make a big old hashtag, and you're going to put 45, 45, 90. It's already there. And here's what we know. Let's label this triangle. If it's isosceles, what do I label on there? Two sides with tick marks. Tick, tick. And what about this angle right here? What should I put here? You can put 90 or the little 90-degree perpendicular symbol, right? Looks like a square kind of. And then what angles go for these other two? 45. 45. Let's try it again. Sometimes it's hard to write on this thing. 45, and then this is 45. Those are both degrees. Okay, so here's the deal. The missing leg, I'm going to call A. The variable will be A. The other missing leg has to be what? No. A. Because it's isosceles. They're equal, right? They're congruent in their measurement. So A and A. So here's the deal. A is across from what? What's this? A is across from what? So underneath 45, we're going to put A and A. Okay? Okay. All right. Now, here's the weird part. The hypotenuse is supposed to be times square root of 2, right? So that's what we're going to do. We're going to write A square root 2. And you're going to write that in your little table here. A square root 2. So these are the rules of a 45, 45, 90 triangle. You should wake up. I need everyone's head up, please. So, here's the deal. We're going to take that information, and by the way, you're going to fill in these bottom three, but there's different types of problems we're going to see. So let's scroll down to number 1, okay? All right, I see a triangle. Is this a 45, 45, 90? How do you know? Okay, so one of the angles is 90, and one of the angles is 45, so the other one has to be, it has to be 45, okay, because it adds up to 180, right? 90 plus 45 equals 180. That's the triangle sum theorem that we did not forget from last year. So long ago, right? Last year. 2018. All right, so anyways. So we got a 45, 45, 90 triangle, so I'm going to make my little chart. Everyone's going to write a fat hashtag, right? He said I'm a handsome teacher. All right. Here we go. 45, 45, 90. Now, what do I always write in the second row? A square root of 2. A square root of 2. All right. Now here, a ditty. What's the ditty, Miss Merle?
What was the song that drove us crazy and we're still in therapy?
Oh, it's not. Oh, man. That's an old song. All right. So let's talk about this, though. Now, 8, right? We have one side length that's labeled here, right? Red hoodie? Huh? All right, so 8 is across from what angle? 45. So guess where I'm going to put the 8? Underneath the 45. Okay? Now, here's what you got to do every time. Okay? You write your table, you fill in one thing, and you're going to think of these things as equal. A equals 8. So I'm going to write that down. A equals 8. Because it's right above each other. Okay? Right? Girl with phone in hand. All right. Now, if A is equal to 8, that's it. I don't need to solve anything. A equals a number. So that means under this A, what am I going to put? 8. Easy. And then over here, A square root of 2, I'm going to replace A with 8. So it's going to be 8 square root 2. Do you see how that works? Now let me say this in math terminology. If you have a 45, 45, 90, and you know one of the legs, the other leg is the same, and the hypotenuse is that same number with the square root of 2 next to it. Okay? That's it. Now, if they were all like this, that would be kind of easy. Now, on your assignment, most of them are kind of like this, so mostly shouldn't be that bad. Okay? But I'm going to show you the harder ones. There's a way for this to get more complicated, so I do want to show you so you have it in your notes, right? So everybody, even with a red hoodie or a phone in your hand or headphones in your ears, you still want to make sure you're paying attention and doing the right thing, right? All right, so let's look at example 2. We're going to skip over Pythagorean theorem. Number 2. Is this a 45, 45, 90? So, does everyone see we do have a 90, right? Now, I don't see 45, 45. I don't see equal sides. But what do these arcs mean? No. They're congruent. Same measurement, right? So here's the deal. If these angles are congruent, what do they both have to be? 45, because otherwise it wouldn't add up to 180. So 45 plus 90 equals 180. Cool. That means this side and this side are congruent. Yeah. Now, what do I have to write next to my, over here? My chart, which is a big old fat hashtag. You don't have to make it this wide, but whatever. Okay, so 45, 45, 90. Right? What goes on the second row? A, 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 square root of 2. All right. So far, so good. Now, if you just were to guess, where do you think we should put 10 square root of 2? At the end, because it looks like it, right? But that would be wrong. Here's why. 10 square root of 2 is across from what? 45. So that means underneath 45, I got to put 10 square root of 2. Isn't that weird? Sometimes you see some weird stuff. So, here's what we're going to do. What did I do last time with A and 8 right here? I did what? What's this right here? I set them equal. So guess what I'm going to do here? A and 10 square root of 2, I'm going to set them equal. A equals 10 square root of 2. Cool? Is A by itself? It is. So guess what I'm going to put right here? 10 square root of 2. Okay? So it makes sense that these should match. But what on earth do I do for the last column? Okay, so even though it already has a square root of 2, I'm going to multiply it by another square root of 2. All right? So here's the deal. I'm gonna do this one out here. A, we said, is 10 square root of 2. Actually, I'm going to write here. A square root of 2. And I'm going to replace A with this. 10 square root of 2 square root of 2. See how that works? So I took this thing right here, and I substituted A with this. Now, let's see what y'all remember. 10 square root of 2 times square root of 2. If you're sleeping, let's wake up. What is the square root of 2 times the square root of 2? I think someone said it. So you could have said square root of 4, not just 4. But what is the square root of 4? Regular 2. Okay? So if you have a square root times itself, the square root goes away. So square root of 2 times square root of 2 is just 2. Cool? So that means I have 10 times 2. Right? This 10 times 2. What's 10 times 2? 20. So guess what we got? 20. That was a weird one, right? But if you follow the steps in order, you'll be all right. Okay? You might have to do a little bit of algebra. Okay? Yay, algebra. All right, flip it over. Let's try example 3. All right. Is this a 45, 45, 90? Well, I see a 90. What do I know about these two sides right here? They have to be the same because they're both x, so I'll put a little tick mark. If the sides are equal, that means these angles are what? They're both, congruent. So that means if these angles are equal, what do they have to be? 45 degrees. So that's a 45, 45, 90. Let's make a table. (45, 45, 90). What do I always put here? A. A. A square root of 2. Now, I have a 5. 5 should go where? Where do y'all think 5 would go? You would think, but 5 is across from what? 90. This is going to be the most weird one. Bet. Okay? Now, what do I do with these two things again? Set them equal. Okay, that's what I did the last two times. I set whatever is in a column, set them equal. So, off to the side here, A square root of 2 equals sign 5. Okay? So, this is a situation where A is not by itself. Okay? I need to get rid of a square root of 2 on the left side. How do you think I should get rid of a square root of 2? That wouldn't, okay, that would get rid of the square root, but not the 2. So here's the deal. To get rid of any number that's being multiplied, we need to actually divide, okay? So I'm telling you, in this weird situation, which you will see on the assignment, okay, you set them equal, and you have to divide by the square root of 2. So watch out. So divide square root of 2 to cancel it out. Cancel. Divide square root of 2. Now hold on. What did Miss Moreau say about square roots on the bottom?
You dirty, rotten.
So Miss Moreau says square roots on the bottom is as bad as cuss words. So you should be troubled in your spirit that you see a square root on the bottom. Do y'all remember how to get rid of the square root on the bottom? That's when you multiply times the same square root. Okay? So check it out. Square root on the bottom times same square root on the bottom times same square root on the top. And we will get our answer. So 5 times square root of 2. What's 5? Regular 5 times the square root of 2. What? What? 5 square root of 2. Number, square root, put them next to each other, right? And then we just did this. Square root of 2 times square root of 2. Regular 2, right? Square root times itself removes the square root. Now that ugly fraction that cannot be reduced, that is a. So over here, what do I put underneath a and a? This, okay? So here we go. 5 square root of 2 over 2. 5 square root of 2 over 2. Is that pretty? No. But that's how you do it. For real, okay? So I know number 1 was easier, number 2 was medium, and then this one's kind of madness. But if you can do that, you'll be aight, okay? Sorry, what? But these would be the answers for number 4. You set up the table and solve it like that.